Hi, here we're going to be doing a problem with closed and open pipes. So we're told that we have a pipe that is 2.46 meters long and the speed of sound is 345 meters per second in air. So L is 2.46 meters and the sound is 345 meters per second. So in part A, we're asked to determine the frequencies of the first three harmonics if it is an open pipe. So they're asking for F1, F2, and F3. Remember, to find F of n, we just go n times F of 1. So in each of these, it will be F1, this is 2 times F1, and that is 3 times F1. All right, and then in part B, we're asked to find the frequencies of the lowest three harmonics if it's closed at one end. Notice they're saying the lowest three. It's not going to be the first three harmonics, remember, because we don't have even harmonics. So we'll have F1, F3, and F5 are what we're looking for. So if you'll remember from our last video, we've determined that L is n over 2 lambda for open pipes, and L is n over 4 lambda for closed pipes. We don't have lambda, but we want to find the frequencies, not the wavelength. So we also have velocity is lambda f, and that's true for both open and closed. So let's rearrange this to solve for lambda and then plug that into each of those equations. So if we rearrange this, we'll get lambda is velocity over frequency. If we put that in here, we get the length for an open pipe is n over 2 times v over f. N over 4 times velocity divided by frequency. Right? So these will give us our frequencies for each of these. So we can find F1 first and then multiply by our n's, which is probably going to be the easiest. So let's say n is 1, so we have v over 2f1. If we rearrange this to solve for f1, we're going to multiply both sides by f1, and we're going to divide both sides by L naught, sorry, not L naught, by L open pipe, and that's going to give us F1 is equal to V over 2L. So let's plug in our numbers for F1. Equal to 345 meters per second divided by 2 times L, 2.46 meters. This works out to be 70 hertz. Remember, hertz just is 1 over seconds. So F1 is 70 hertz. F2 is going to be 2 times F1, just 2 times 70 hertz. That's going to be 140 hertz. F3 is 3 times F1, 370 hertz, and that is 210 hertz. So those are our frequencies for the first three harmonics. Now in part B, we're going to find the lowest three harmonics, F1, F3, and F5, if it's closed. So we already got this equation. Let's do exactly what we did back here. If n equals, if n equals 1, then we've got L is equal to V over 4F1. If we rearrange this to solve for F1, multiply both sides by F1, divide both sides by L, we will have F1 is equal to V over 4L. So let's take that over here. So F1 is equal to 345 meters per second divided by 4 times L, that's 2.46 meters, and that's going to give us 35 hertz. Notice the fundamental frequency for a closed pipe is going to be half of what the fundamental frequency was for the same length of a pipe that's open at both ends. So F1 equals 35 hertz. F3 is going to be 3 times that. We're going to find it the same way we did over here. That's going to be 105 hertz. 105 hertz. F5, same thing again, multiply it by 5. That's going to be 175 hertz. Seven. All right, so in this problem, we were given the length of a pipe and then just the speed of sound in air, which you could look up. And using those two, we can find any harmonic in question. You could also find, as we showed over here, you could find the wavelength if they asked for the wavelength given the length of the pipe. So that's a problem for waves in closed and open pipes.